Okay, hello guys. Happy Wednesday. Welcome back to our August week 2. Okay, hi guys. Happy Wednesday to you. And we are continuing with our chapter 8. Okay. Yes, hello Karen. Hello Zindong. It's just the two of you again. Right, so guys, we were here. Did you remember what I taught you last week? Did you remember this? Do you remember I said proton number is equal to electron number? Okay, 16. Okay, and your valence electron, do you remember what is valence? Okay, excuse me. Do you remember what is valence electron? Valence electron is the outermost electron. That is what we focus on because the outermost will determine how reactive you are. Right? It will determine how reactive you are, whether you are very reactive or not. Right? Like I said, if you are 8 on the outside, or we call it octet, you're full, that means you're very stable. Okay, you're very stable. And if you are, okay, neon is also 8. Okay, I erase this already. And then helium is 2, duplet. They are very stable. Remember this? Remember this? And then if you're like sodium, you have 1 on the outside. You're very crazy because you're very desperate to throw this away. If you're chlorine, 7, you're also very crazy because you die, want to take 1 more. All right, so valence will determine where they are. Okay, like I told you before, guys, group 1 is valence electron 1, group 2, valence electron 2, 3 to 12 we skip, 13 is valence electron 3, 14 valence electron 4, 15, 5, 16, 6, 17, 7, 18, 8. Remember this? Remember this? So, guys, group 3 is not like, oh, group 3, valence electron 3, we don't deal with 3 to 12. Okay, 3 to 12 we can skip. So it's valence electron 1, 2, 3. 3 is like 13. Okay, remember this, I hope you do, very easy stuff. Okay, so today we are almost learning the same thing again. Okay, we are learning almost the same thing again. Okay, shall we look at this? Shall we look at page 4? Guys, give me a moment. Let me check something. Okay, right. So I think we are on time here. Okay, hang on. Okay, because some people here. Hang on, let me check something. Okay, Jenny, hello. Good evening. Wow. Was sorry, Jenny. I forgot to send you the video last week. Sorry, forgot already. Okay, so yeah, you are going to be a bit blurry today, because I haven't sent you the thing. Okay, so guys, let's look at page 4. Last week we drew this actually. Okay, so it was kind of a big thing you missed, Jenny. So I'm sorry, I didn't check the request form yet. I haven't sent you the form yet. No, I haven't yet. Sorry, it's been really busy. I don't have the time. So sorry. My schedule is a bit too full. Okay, so let's look at this, shall we? Right, so guys, do you remember magnesium? Shall we look at magnesium? Okay, Jenny, try to pick up whatever you can, right? And if you want to, I can send you this video as well. Try to make you piece things together. Right, so if you remember, magnesium is arranged as such, 2.8.2. Okay, 2.8.2. That means the valence electron of magnesium is 2. They have 2 on the outermost. Okay, so those who attended my class last week, Karen and Zindong, what will magnesium do? If you are magnesium, are you happy with 2.8.2? Are you happy with 2.8.2? Anyone? Can anyone tell me? You are magnesium right now. You are 2.8.2. Are you full? Are you octet? No, isn't it? So what will you do? As magnesium, what will you do? How do you make yourself full? How do you make yourself full? You have two choices here. Either you take 6 to make yourself 8, or you donate 2. Yes, okay? So you will die, throw these 2 away. Right? When you do this, when you donate these 2 electron away, you will become magnesium ion. Do you remember what is ion? We learned this the first week. Ion is anything that has charge. Okay? So when you throw 2 away, now you become 2.8. Is it stable already? You are happy now. You are happy now, right? And you are now magnesium ion, square bracket, 2 plus. Why is it 2 plus? Because you threw 2 negative away. You throw 2 electron away, right? Electron is negative, right? When you throw away 2 negative, you become 2 positive. Does it make sense? Does it make sense? You throw 2 negative away, you become 2 positive. So 2 positive lah. Okay, do not write positive 2. You have to write 2 positive. This is a formula, and it needs to be a square bracket. It needs to be a spare bracket. Square bracket, what am I saying? Square bracket, okay? And then can you see your octet now? You are already octet. You are already 8. You are already full. So you are happy. As magnesium ion, you are already stable. You are happy. Okay, so generally this might look a bit blurry to you. The first layer can put 2, second layer can put 8, third layer can put 8, fourth layer can put 8. The point is to fill up everything, right? So now magnesium 2.8, he's happy now because 8 is already full. This guy, not very happy because there's 2 on the outside. So I throw away that 2, right? So try your best to absorb as you can. Okay, guys, moving on. Let's look at chlorine. Let's look at chlorine. As chlorine, are you happy? No. So what will you do? How do you make yourself full? Yes, you take 1, right? You accept 1 electron. You accept 1 electron. Now you become 2.8.8. You are now chlorine ion. Right? You are now chlorine ion. So are you happy now? Very happy. You see, chlorine is very happy now. Okay, ion is very happy now because I took 1 more already. I'm already stable. Remember square bracket and then 1 minus. Okay, you might say, hey sir, it's 1 minus, right? Why is the 1 missing? For chemistry, we don't write 1. 1 we don't write. It's like H2O. Do you write H2O1 or do you just write H2O? You get what I mean now? You get what I mean? So in chemistry, we don't write the 1. So 1, we just leave it. So you know it's a 1. So same thing lah. Same thing. So you see 1, you see nothing here, that means it's a 1. Okay, this is a chlorine ion. Because when I take 1 electron, when I take 1 negative, I become negative 1. Right? You get what I mean here, guys? You get what I mean? I take 1 negative, I become 1 negative. Am I making sense here? Am I making sense here? Guys, are you so far okay? Are you so far okay? Jenny, I'm sorry you have to make do with this. Okay, I hope you can try your best to understand. Okay, okay. So moving on, let's look at aluminium. Okay, please add this for me. This is aluminium atom. Aluminium is 2.8.3. Are you happy as aluminium? Are you happy? Of course not, isn't it? Okay, 3 is never happy. So what will you do? Guys, as aluminium, what will you do? What will you do? Jenny, you wanna try? You wanna try? How do you make aluminium happy? How do you make aluminium happy? You have 3 on the outside. Okay, Karen, you're correct. Okay, so what's gonna happen? You will donate 3 electrons. Right? You will throw that 3 away. You might say, sir, why not take 5? Because take 5 is harder than throwing 3. Right? It makes sense, right? Okay, so this is how you draw it. Okay, guys, draw together. Aluminium. Now you have 3 layers. Okay, now you have 3 layers. Okay, so the first layer got 2, second layer got 8. Okay, third layer got 3. Okay, remember I said this, guys. You fill in 1, 2, 3, 4. before you fill in 5, 6, 7, 8. Electrons, they are in pairs. Can you see the second layer? Can you see them in pairs? Right? Do not draw them evenly like this. Your answer is wrong. Okay, so what will you do? You throw 3 electrons away. Now you become aluminium ion, which is 2.8. Okay, so now you look like this. Okay, remember a square bracket. Guys, when you throw 3 electrons away, what's your charge? When you throw 3 negative away, what are you now? What are you now? You throw away 3 negative. What are you now? Anyone? Anyone? You throw away 3 negative. So what are you now? No one knows? Yes, you become positive. How many positive? How many positive? You throw 3 negative away. So you become 3 positive. Am I making sense here, guys? Am I making sense here? Am I making sense here? Yes, Yes, Is there a total number? What do you mean total number? For, sorry? For both, just follow the proton number. Okay, just follow the proton number. You see, sulfur is proton number 16, electron will be 16. Because if you have 16 positive, you have 16 negative. This is a law. Remember proton number? Remember proton number? Just look at your periodic table. You see, sulfur is 16. Okay, just now we drew aluminium, right? Aluminium is 13, right? So 13 is 2.8.3. Because 2 at the first shell, 8 at the second shell, 3rd at the third shell. So 2 plus 8 plus 3 is 13. A lot to absorb, I know, because this is from last week. Okay, I don't know whether you can make something out of it. Right, if you don't, it's okay. I'll send you the video. Right, so guys, next, nitrogen. This is nitrogen atom. Are you happy as nitrogen? Are you happy as nitrogen? No, you're not. You are 2.5. Okay, 1, 2, 3, 4, 5. Okay, so you're 2.5. So as nitrogen, what will you do? Guys, as nitrogen, what will you do? Take 3, correct? You will accept 3 electrons. So now you become nitrogen ion 2.8. Okay, so now 2.8. So when you take 3 electron, what is your charge now? 3 negative, thank you. Square bracket, I remember. So now you're happy. Nitrogen ion is happy. So the point of becoming an ion, like these, they do, okay? Why do they become ion, become ion, become ion, become ion? These are atoms, right? Like I said, atoms are non-metal. Sorry, atoms are metal. Why would they change to ion? Because they want to be happy. They want to go from not perfect to being perfect. You see, everyone is perfect now. Everyone is happy. Their point is to be happy. Okay. So guys, why don't you try the last two? Can you please try the last two? Can you please try the last two? And I'll give you a tip here. Sodium atom is 2.8.1. Oxygen atom is 2.6. So you do. Come. I'll give you 3 minutes. Is it enough? How come you do? I'll wait for your answer. Guys, do let me know when you're done. Do let me know when you're done. I'll give you the answer. Please don't take so long. Guys, are you done? Are you done? Are you doing it? I hope you are. Are you done? Done? Okay. So the answer, this is sodium 2.8 0.1. Okay, not a very happy guy. So he will donate 1 electron. Oh, guys, if you notice, most that donate electron, all that donates electron, they are metals. Magnesium is metal, aluminum is metal, sodium is metal. Okay, so when they donate, this thing will become 2.8. Okay, plus, and this is your sodium ion 2.8. Correct? Is this correct? Jenny, did you try? I mean, if you don't, it's okay. I understand. Did you try? Oh, are you correct? Are you correct? So oxygen is 2.6. Okay, good. Not the last one. You mean this one, or this one? Oxygen or sodium? Oxygen or sodium. Okay, this one will accept 2 electrons. This one, is it this one? The sodium one? Okay. Why? What did you get wrong here? Just curious. What did you get wrong here? So oxygen will take 2 electrons to become 2.8. Okay, and oops, this becomes 2 negative. This is your oxygen ion 2.8. You put negative instead of plus. Okay, okay. Okay, that's good enough. That's good enough. Okay, you'll get it. So this is 2 negative. Okay, guys, are yours correct? Is yours correct? Any of yours different from mine? And those that accept electron, they are usually non-metal. You see, oxygen is a non-metal, nitrogen is non-metal, chlorine is non-metal. All right, guys, cool, cool. Hey, teach you to see something. I'll teach you to see something. Okay, guys, just to tell you, the valence electron will determine your group. The shells will determine your period. Okay, so what do I mean? What do I mean? You see, magnesium is group 2, period 3. Because got 3 shells, so period 3. How do I know? How do I know? You see magnesium, You see magnesium, group 2, period 3. Cool, So cool, yeah, sure. Jenny, why not you WhatsApp me? Sometimes, okay, here's the thing, you WhatsApp me, it will be faster. Do you have my number? Do you have my number? WhatsApp me will be faster because I'll check my WhatsApp all the time. Oh, you don't, Okay, guys, you can save my number down. Anything you can come and ask me. If you want any video, come and ask me. Okay, including previous one. If you say, sir, I want chapter 5 video, come for me. I'm okay. Right? Because I check WhatsApp all the time. Right? Because lately my students are having exam, right? They are asking me, oh, sir, can you send me all the videos for chapter 3? Oh, okay, then I'll send it to them. That's why I have no time to read my request form. I don't usually check my request form. So you WhatsApp me even faster. Okay, so yeah, give you one more example. Like you see chlorine atom. Okay, this is the group. This is the period. So chlorine is a group 17. Like I said, we don't care 3 to 12, right? We go from 1 to 13 to 18, right? So group 7, this 7 valence is a group 17, period 3. You see, See, chlorine, group 17, period 3. Right? We don't care 3 to 12. Again, valence electron 1, group 1, valence electron 2, group 2, valence electron 3, group 13, and 4, 5, 6, 7, 8. We don't care 3 to 12. We don't bother with it. Okay? Right? And here's the same. Aluminium is group 13, period 3. Am I making sense? Am I making sense? Nitrogen is group 15, period 2. Group 15, period 2. Sodium, group 1, period 3. Group 1, period 3. Oxygen is group 16, period 2. Group 16, period 2. Am I making sense here? Guys, am I making sense here? Am I? I hope I am. I hope I'm making sense. Okay, really easy stuff. This is nothing tricky or whatever. This is very straightforward. Okay, and guys, okay, let's move on. Can we move on? Are you guys okay so far? Are you guys okay with these? Are you guys okay with these? Jenny, if you're okay with this, right? This is basically the same thing. So last week's stuff, when I send it to you later, you just watch and skip ahead lah. Okay. Okay, so guys, moving on. Right, so guys, let's talk about real life example. Let's talk about real life. Okay, in real life, remember I said atom is metal. Remember I said the first lesson, remember I said atom is metal. And then ion is metal plus non-metal, right? Okay, in real life, changing from atom to ion is a bad thing. It's a bad thing. Why do I say so? Okay, let me give you an example. I think I mentioned this before. Right, if you go to hardware store and you buy a hammer, you buy a new iron hammer, the iron hammer is an atom because it's pure iron, right? Because it's iron, because it's metal. Your hammer is metal, correct? After, okay, let's say you leave it around, you leave it on the table or whatsoever, you leave it, okay, sorry, not table, okay, you leave it outside and let it rain, okay? Let rain, you just leave it there. A few maybe days later, you will start to see a layer of rust, and that rust is ion. Because the iron already react with the oxygen in the air to form rust. So can you see? Atom going into ion, this is a form of corrosion. You know what is corrosion? Guys, do you know what is corrosion? Rusting is a form of corrosion. Corrosion is 腐蚀, if you need Mandarin. Okay, so corrosion is when your thing starts eating up. Am I making sense here? Am I making sense? So this thing will start to eat up, start to corrode. So this is a bad thing, right? So especially for iron, right? You see, metals such as iron can donate electron to form stable iron. So changing from atom to ion is a bad thing, right? Because this creates problems to iron structure. Rusting takes place when you have dampness, air, and salt, right? Strength and hardness of a structure will reduce. So how do you prevent rusting, guys? How do you prevent rusting? I'm sure you know. Number one is to paint it. The cheapest way for your gate to not rust is to paint it, right? But of course, painting doesn't last for very long. You can cover it with plastic, also doesn't last very long. Okay, this happens to dumbbell. Have you been to a gym before? Have you been to a gym before? They will wrap the dumbbell with some rubber or plastic so your dumbbell doesn't rust. Do you know what is electroplate? Do you know what is electroplate? Okay, electroplate is when you take a metal and you coat another metal with it. Right? Let's say you have iron, you coat it with a layer of zinc. This is electroplate. Okay, so let's say you have a piece of iron, you coat it with a layer of zinc. This is electroplating. And this, guys, this, we call it galvanized steel. Have you seen this before? Have you seen this before? I'm sure you have seen iron like this before. You can almost smell the picture. Right? When you touch this and you smell it, oh, that iron smell. The smell that smells like blood. Have you? Have you seen this before? Have you seen this structure before? You go outside to your lamppost, you see this? You know lamppost? You know lamppost? Your house outside has lamppost, right? The lamppost is made from this. Right? You can almost smell it. This is galvanized iron. So outside there's a layer of zinc. Right? Even you say, sir, I've not seen this before, and I'm sure you have seen this. Have you seen this? Have you seen this? They use this on roof. If your neighbor uses this kind of roof, it's noisy as shit because when it rains, you can hear it. The tak 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 sound. This is the thing, okay? This is your galvanized iron, okay? And of course, we will learn this next chapter, or you use alloy. Guys, do you know what is alloy? Do you know what is alloy? Have you heard of the word before? Have you heard of alloy before? Do you know what's an alloy? Guys, do you know what is alloy? Okay, alloy is when you take a metal, you add another metal to it, you melt it together to make it stronger. Okay, for example, when you mix iron with carbon, which is a pencil lead, you will get something called steel. Have you heard of steel? Right? If you add iron and chromium and nickel and molybdenum, things like that, you get something called stainless steel. I am sure you have heard of this. You know what is stainless steel? 不锈钢. The thing found at your pot. I'm sure your mom uses a stainless steel pot. Does she? Right? Stainless steel pot is every auntie's dream. My mom's dream, at least, she has a collection of stainless steel pots. Okay. Anyway, so this is what happens lah. We want to prevent rusting lah. We paint it or we electroplate it. We to make it into alloy. Okay. So guys, as for this isotope, I'll go into this next week. I'm not gonna rush this. Okay. So we'll chill for now. Right, guys. Can we do some exercise? Can we please do some exercise? Jenny, how many lessons you have missed? How many lessons you have missed? 1 or 2? Oh, 2. Oh, no wonder. Oh, then you missed a lot. Because last 2 lesson was quite crucial. Okay, anyway, no matter. Okay, guys, have you done question 6? Have we done question 6? Oh, exam, I see. Also, how's your exam? How's your exam? Did you do well? It was okay. Science, leh? Was science okay? Oh, it was okay. Okay, cool. I mean, I don't care about other subjects. I only care about science. Okay, sorry, not sorry. Okay, paper was easy. Wow, nice. Love to hear this, right? When my students say things are easy. Okay, guys, have we done question 6? Have we done question 6? Karen, have we done question 6? This was 2 weeks ago. No, sorry, last week. Have we done question 6, page 11? Oh, you don't have it, ah? No, shit. Sintong, have we done this? No, ah? Okay, so I'll let you do some homework, guys. Can you please do question 6? Can you please do question 6? Karen, I forgot. I didn't send it to you? I didn't send it to you, ah? Oh, damn it. I forgot things again. Sorry. I did not send it to you? Serious? Wait, I did. Oh. Oh, you don't have it to write. Then okay, then can you refer to your notes and write it at the paper? Can you do that? Okay, guys, can you please do question 6? And question question 6 and question 15. Okay, and okay, 6 and 15 lah. 6 and 15. If you have the time later, you do 16 also. It's 6, 15, and 16. Okay. I'll give you. Is 10 minutes enough? I'll give you 10 minutes. I'll give you 10 minutes. I'll be back. Right, I'll be back. I'll let you do. Right, 10 minutes. 10 minutes. I'll be back at 5:13. Okay, 5:13. I'll see you there. Okay, are you guys done? Are you guys done? Can I give the answer? Can I give the answer for question 6 first? Right, like I said, this question 6 is a very typical exam question. They will give you a periodic table. They will give you fake alphabets, which doesn't represent the real thing. And they want you to answer the questions, okay? They want to test you whether you know how to read the periodic table. Right? Are you guys done? Have you done at least 6 and 15? That's all I want for now. 6 and 15, just 6 and 15, don't worry. I just want 6 and 15. You guys done? If you're done, then I will just begin lah. So how are the elements arranged? By increasing proton number. I already told you this, like many times. Increasing proton number. B, which elements belong to the same group? Same group means the same column. Who is the same group here? That would be P and U. Okay, P and U. Next, which element exists as a stable atom? Explain your answer. Stable is the last group, the one with 8 valence electron. Remember, R is the stable one. Okay, because they have they achieved duplet or octet electron arrangement. They are already full. Okay, they are already full. And then number D, an element has nuclear number. I think I said this last week. Nuclear number is the total number, 32, and proton number 16. Okay, if you forgot this, let me repeat again. Nuclear number is the total number in the nucleus. You see, what is in the nucleus? Inside your nucleus, you have the blue color ball, the plus one, which is proton. You have the yellow color ball, which is the one with no charge, the neutron. So proton plus neutron is the nucleon. Right? So they say proton is 16, total number is 32, Oh, where is the element located? Okay, so since it's where, then we don't care about the 32 already. We just need to arrange the 6. So 16, sorry. 16 is 2.8.6. Okay, 2.8/6. So 6 is group 16. As I said before, group 16. And then we have 3 shells. So this is period 3. Okay. Guys, are you okay? Are you okay? Jenny, this might look like alien to you because you missed 2 classes. Of course, it will look like alien to you. Right? But can you at least make something out of it? I hope you do. Right, so electron arrangement for P, Q, and T. Okay, P is number. Okay, this is 1. This is 2. P is 2.1. Because 3 electron ma. 3 electron ma. So this is 2.2, 2.3, 2.4, 5, 6. Q is 2.7. Okay, and then 2.8, 2.8.1, 282, and then T is 2.8.3. Did you get this? Did you get this? Karen, Sintong, are you guys getting this? Yes? Okay, if we get it, then it's good. If we get it, it's good. Okay, next. Let's go to 15. Okay, 15. So element X loses 2 electron to element Y. Like I said, the one that donates is usually the metal. The one that accepts is usually the non-metal. Okay, just to let you know. Right, what type of ion would X form? When I donate electron away, what am I forming? Am I becoming a positive ion or am I becoming a negative ion? Which one? Positive or negative? Guys, positive or negative? I am throwing electron away. So I am a positive ion. Correct? Correct? Because I'm throwing electron away, ma. I'm throwing negative away, ma. So I'm positive. Next, B. Identify the element represented by X. Oh shit, how would I know this? Okay, guys, we skip B. This is not really a good question. So C, what type of ion would Y form? Y would become a negative ion. Okay, element represented by Y, not really. Okay, if you want, you can say metal or non-metal, because I can't tell what element it is. Okay, so X is a, oh, they're asking again. Okay, X is a metal, Y is a non-metal. Guys, so far so good? So far so good? Do you have any question here? I would assume that's a no. Right, I would assume that's a no. Right, next, 16. I'll just give you the answer for here. So electron arrangement for lithium atom, this is the atom. So this is 2.1. Can you see 2 at the first shell, 1 at the second shell? So for the ion, it's 2. Now I threw 1 away. Now I have 2 at the first layer. Charge of 3 proton is positive 3. 3 positive, 3 proton. 2 electron is negative 2. So the total charge is positive 1. Okay. So guys, can you change this to lack? Lack of 1 negative charge cause a positive ion to form. Lithium atom donates 1 electron to form lithium ion. Lithium ion achieves stable duplet arrangement, which is 2. Okay, the first shell is 2. Next, oxygen, electron arrangement is 2.6. 2 at the first, 6 at the second. Oxide ion is 2.8. Okay, there's actually 1 missing here, they forgot to draw. Charge of 8 proton is positive 8. Charge of 10 electron is negative 10. Total charge is negative 2. You might say, hey, sir, I thought charge is 2 negative. yeah, when you write it here, it's 2 negative, but when you write it, the charge is gonna be -2. Don't ask me why, this is chemistry. Okay, excess of 2 negative electrons causes a negative ion to form. Oxygen atom achieves, receives 2 electron to form oxide ion, stable octet electron arrangement, which is 2.8. Guys, am I making sense here? I hope I do. Am I making sense here? If I'm not making sense, then please let me know which part am I not making sense. Which I think, Jenny, you skipped the previous 2 episodes, so this episode's development is gonna be a bit out of place. WhatsApp me, WhatsApp me. Don't forget. Remember to WhatsApp me. Okay, guys, I think that would be all for today. I'm not going to do too much today because most of you are having exam. I just want you to remember what we learned last week, like an extended version of last week, right? So last week's lesson and this week's lesson is almost the same. It's just to let you do more exercise and let you understand more, right? Next week we shall go to isotope. Okay, guys. One more thing to say. One more thing to say. If you really want to understand what is isotope, go and watch Oppenheimer. They mention it in the movie. Right? Any of you watch Oppenheimer? Oppenheimer? The movie in theaters currently. Everyone is talking about it. It's either Barbie or Oppenheimer. Go watch Oppenheimer. They mention it in the movie. Is it 18? No, it's 15, 16, I think. 15 or 16, because my student who's Form 4 this year, they went and watched Oppenheimer, Oppen. Go Google, you understand. Go watch it. It's a 3-hour movie. Go watch Oppenheimer. They mention isotope inside. Right? If you have the time. Right, guys. I think I will stop here. That's weird. Okay, maybe check another cinema and see. Right, guys. I think I'll end it here. Nice seeing you all. I will see you next Wednesday. Okay, have a great one, guys. I will see you soon. Okay, take care. See you. Bye-bye.